You had the right answer. 0.05. All right. Okay, so yeah, that one should be 0.005, which, yeah, it's not very much difference between the two. Okay. All right, then. Talk about the second type, and that is Simpson's rule. Simpson's 1/3 rule. See why it's called that in just a second. Also known as. But it uses not trapezoids, not rectangles. It uses a parabola. And developing it takes some time, and the book goes through it, but let's just hit the highlights here, okay? All right. What we're going to do, a to b again, of f of x, approximating integral a to b of f of x dx. How we're going to do it here? Well, Simpson's rule, as far as the subintervals goes, let's say we use n equals 6. 1, 2, 3, 4, 5, 6. Okay. So we got n equals 6. X of 1 is here, 2, 3, 4, 5, and 6. Okay? That's all the same. To determine a parabola is what we're going to do. We're going to determine a parabola off of those subintervals. And to determine a parabola, I don't know if you've seen it before, but you need 3 points. 2 points determine a line. 3 points determine a parabola. And so we're going to go with a parabola based on 3 points. And the 3 points, so 1, 2, 3, so I'm going to divide this up. It's n equals 6, but it actually 1, 2, 3. All right, so then there, 1, 2, 3 there. Okay. So we actually kind of skip one, if you will. I mean, we're not going to, but you'll see how it works. So what we do is this point, along with this point, along with this point, that's going to determine a parabola, and they have a much better picture in the book. But that determines a parabola right here. And through a little bit of work, call this A1 right here, A2 and A3 for notational purposes. But that parabola is not quite the same as that curve there, because it's a parabola, and this is, I don't know what it is, x cubed or x to the fourth graph, whatever it is, but it's an approximation. So I'm going to determine there those 3 points determining that parabola. I'm using that point, and that point. It's kind of interesting to see how it all works, but it does take 3 points, and off of those 3 points you can determine a parabola. Well, turns out then, if you look at the area A1, if you find the equation of that parabola, using the equation of that parabola that comes from those 3 points, here's what A1 winds up being. It comes out to be delta x over 3 times f of x sub 0 plus 4 f of x sub 1 plus f of x sub 2. Like I said, I'm doing a bit of my waving of my hands here. Ta-da! It turns out to that. But if we determine the parabola, so this comes from the parabola made by f. What is it? F of x sub 0, f of x sub 1 and f of x sub 2. I mean, like, I'm not going to make you develop that. They've got it in the book. Like I said, it's kind of interesting to see how they get all the parabola stuff to work. But it comes out to be, I don't remember what it is. I didn't look at it this time, but it comes out to be, an ax squared plus bx plus c type of equation. And then, based upon plugging in the numbers and things like that, this is what it comes out to be. That A1, talking about the area under this parabola right here, comes out to be delta x over 3, f of x sub 0 plus 4 f of x sub 1 plus f of x sub 2. Look it up in the book if you don't believe me, okay? All right, now, similarly, I can do the same thing right here in the middle. I've got 3 points for A2 here. That's going to determine this kind of thing for a parabola. And so A sub 2, which is the area under that parabola, comes out to be delta x over 3. Guess what? F of x sub 2 plus 4 f of x sub 3 plus f of x sub 4. And then similarly, A3, it comes out to be delta x over 3 times f of x sub 4, 4 f of x sub 5, f of x sub 6. So if I add these three together, I get my approximation. Integral from a to b of f of x is approximately, by that process, well, again, factor off the delta x over 3 and look at what I've got as far as f of x values. Well, I've got f of x sub 0 plus how many f of x sub 1s do I have? Well, this is the only f of x sub 1, isn't it? So I have 4 f of x sub 1s. How many f of x sub 2s do I have? 2 f of x sub 2s. How many f of x sub 3s do I have? I have 4 of those. 4 f of x sub 3s. I have 2 f of x sub 4s. 4 f of x sub 5s. And 1, last but not least, f of x sub 6. Okay? Well, that's for n equals 6. Suffice it to say, if you change n's, and for Simpson's rule, there is one little note. For Simpson's rule, you can kind of see n has to be an even number for Simpson's rule to apply because of the patterns and all that. But anyway, do you see the pattern here? What if I went to n equals 8? Well, it would follow the same sort of pattern. What have I got? The first one is just 1 times it. But then I've got 4, 2, 4, 2, 4, and then the last one. See that? So if I just say for n subintervals, here's Simpson's rule right here. And you see why it's a 1/3 rule? Because it's divided by 3 here. Delta x divided by 3. Whereas the trapezoidal rule is divided by 2. Simpson's rule is divided by 3, so it's called the 1/3 rule. Simpson's 1/3 rule. All right, but anyway, Simpson's rule for n subintervals. N has to be even. It's the integral a to b f of x dx is approximately equal to then delta x divided by 3, 1/3 rule, times f of x sub 0 plus the one after that is 4 times f of x sub 1. It always starts that way. 4 times f of x sub 1. Then it goes 2 for the next one, 2 f of x sub 2. Then it goes 4 for the next one, 4f of x sub 3. Then it goes 2 for the next one, f of x sub 4. So it's alternating 4s and 2s, you see. All the way until you get to the last one, which the last one would be f of x sub n. That's Simpson's 1/3 rule, Simpson's rule. Okay, so let's go to Simpson's rule for the previous one. Use Simpson's rule, n equals 8. Again, I think I'll need most of that space, so I'll get rid of that. Okay, use Simpson's rule, n equals 8. To approximate the integral 1 to 4 cosine of x over x squared dx. What's delta x here? 4 minus 1 divided by 8, 3/8, or also known as 0.375. So we started a x sub 0, so that would be 1.375. I mean 1. Then x sub 1 is 1.375. Get this right. X sub 0 is the first one, so it's 1. X sub 1, just add the delta x to that. Then x sub 2, add delta x to that. 1.375 plus 0.375 is 1.75. X sub 3 then is 0.375 plus that, which is, by my calculations, 2.125. X sub 4, 375 to that, 2.5. X sub 5, 2.375 to that, 0.375 to that, 2.875. X sub 6 is 0.375 to that, so that would be 3.25. X sub 7 is 3.75 to that, 3.625. And then x sub 8 is 4. So probably helpful, especially on ones where you got 3.75. I guess you could use fractions if you want to, but however you want to. All right, so by Simpson's rule, my integral approximately would equal cosine of x over x squared dx would be approximately equal to what? Well, it's delta x over 3, so that would be 0.375 divided by 3 times f of x sub 0, so it'll be f of 1, plus, what's next? 4. For Simpson's rule, the next one's 4 times f of x sub 1, 4 times f of 1.375. Then the next one is 2 times f of the next one, 1.75. The next one's 4 times f of the next one, f of 2.125. 2 f of the next one, 2.5. 4 times the next one, f of 2.875. 2 times f of 3.25. 4 times f of 3.625. And last but not least, f of 4. See what you get on that. It's just plugging all those in, right? Negative. No. Is that what I got? I get 106,561. But anyway, yeah, it's just plugging in those. I did want to try. Show you that they are pretty accurate here. Even if you have a small number of ends. Error. Let me see. I see yours. Okay. I should have brought my own. Oh wow. Okay. You forgot to divide by 3. Here you go. I will. Yeah. Don't forget to divide by delta x by 3. Don't forget it's divide by 3. Okay. All right. Well, so I think that should let me see if I can get this one real quick. Okay, let's approximate integral 2 to 6, 1 over x dx, which you might note there. Hey, this is one I can do evaluate, and that's my point. I want to compare it to the real answer here. But let's approximate this using A, midpoint rule, B, trapezoidal rule, and C, Simpson's rule. Shouldn't take us too long to do that. All right, so here delta x is going to be what? Oh, with n equals 4 on all. So delta x would be 6 minus 2 divided by 4. It's going to be 3/4, 0.75. So that means x sub 0 is the 2. X sub 1 would be 275. X2 would be 3.5. X3 would be 425. And X4 would be, what'd I do? 275, 35, 45, X4. Wait. Oh, hold on. I'm making this way too hard on myself. 4 divided by 4, it's 1. All right. X sub 0 is 2, so x sub 1 is 3. X sub 2 is 4. Yeah, this is much better. 5 and 6. Just checking, y'all, making sure you go there. Now, for A, midpoint rule, those are what I need for the f of x's for Simpson's rule and trapezoidal rule, right? But what do I need for midpoint rule? I need midpoints. Huh? Well, we're starting at 2 here.
Oh, okay.
Yeah, I changed it on you. We're going 2 to 6. Yeah, x sub 0 is just where we're starting. So in midpoint rule, you know, those are what I'll use for trapezoidal and Simpsons, but for midpoint rule, I need midpoints. And so what's the first midpoint? Well, it's midway between these two. So that'd be 2.5. X sub 2 bar, the midpoint here would be 3.5. X sub 3 bar is 4.5. X sub 4 bar is 5.5. And so in the midpoint rule, we just wrote that out. The integral 2 to 6, 1 over x dx. That's approximately, you know, the sum of all the f of x sub I bars times delta x. The point is there, you're not dividing delta x by 2 or 3 there. It's just the f of x sub I bars times delta x's. In other words, it would be f of 2.5, f of 3.5, f of 4.5, f of 5.5 times all that times delta x. Which is 1, which in this case won't add anything to it. Well, long story short there, calculate that's 1.08, comes out to be approximately 1.08975 for midpoint rule. Trapezoidal rule. The integral 2 to 6, 1 over x dx for the trapezoidal rule is approximately delta x over 2 times, how does it work? F of x sub 0, 2, plus, on trapezoidal rule, they're all just in the middle, there's 2 times it, right? So it'll be 2 times f of 3 plus 2 times f of 4 plus 2 times f of 5 plus then the last one's just f of 6. Delta x here is 1, so this is just 1/2 times all that, which comes out to be approximately 1.1167. And then C, Simpson's rule. The integral a to b, 2 to 6 in this case, 1 over x dx, is approximately equal to delta x over 3 times f of x sub 0, so it'll be f of 2, but then what? 4 f of x sub 1, 2 f of x sub 2, 4 f of x sub 3, and then we're at the end, so it's just f of 6. And that should come out to be, this delta x being 1, that should come out to be 1.1. Now, yeah. Now, just to show you, these are pretty close. All of them are pretty close anyway. The real answer, yeah, we can actually do this one, can't we? What's the integral a to b, 2 to 6, 1 over x dx? Well, I can actually do that one. That's natural log, absolute value of x from 2 to 6. So a natural log of 6 minus natural log of 2, which is a natural log of 3, which is 109,861. Dot, dot, dot. So even with just 4 subintervals, I'm getting pretty close. Midpoint, that's still pretty good, isn't it? 1089, so it's off by 0.9. This is off by a little over, maybe 2, but 0.02. But we're talking hundredths. Hundredths off is all we're talking about.